All right, it's 2:02. We have nearly 30 attendees. Let's get started. So hello, welcome everyone to Ask Seminar Series. This is John, Seminar Coordinator. So I will be moderating this seminar with Kathy and Jennifer, our communication specialists. Just so you know that this seminar is being recorded and we will post the recording on our YouTube channels. And after the presentation, we'll have the Q&A session. So please feel free to bring up any questions you may have. And other than that, I'm going to hand the ball to Kathy to introduce the speaker. So Kathy, please go ahead.
Thanks, John. So I am happy to introduce Dr. Gretchen Mullendore. So she is the director of the Mesoscale and Microscale Meteorology Laboratory at the NSF National Center of Atmospheric Research, NCAR, and as the NCAR Associate Director since January 2021. In these roles, she is responsible for advancing the missions of both NCAR and MMM to advance the understanding of weather and to apply this knowledge to benefit society. A significant portion of MMM's work with the community involves developing and supporting a suite of community weather models used all around the globe, including the model for prediction across scales. Prior to NSF and NCAR, Dr. Mullendore was a full professor at the University of North Dakota. Dr. Mullendore is a fellow of AMS and has received several awards for her leadership, research, and teaching, including the 2017 UND Foundation's /BC Gamble Faculty Award for Excellence in Teaching, Research, and Service, and the 2023 University of California, Santa Barbara Distinguished Alumna Award. So without further ado, I'm just going to go ahead and hand the mic to Dr. Mullendore to give us a talk.
Thank you so much, and thank you so much for inviting me. Hopefully you can see my presentation okay?
Yeah, looks good. Looks good.
All right, awesome. All right, so yeah, I'm Gretchen Mullendore, and you're going to hear me say M cubed a lot. This is our very nerdy way of calling ourselves MMM. I'll be doing two parts, a science update and then also a reflection on the current state of the weather research community in the second part. So let me not forget to also thank Caitlin Hickman, who is the NSF NCAR communication specialist, for helping me put together this presentation. Section 1 is a science update from M cubed and from NCAR, and the contributors, many scientists from across the lab. So first, a step back. If you're not too familiar with NCAR, we are an FFRDC, primarily funded by NSF, but then almost fully federally funded by many agencies, NASA, NOAA, DOE, that our majority funding comes from NSF. And we do fundamental research in Earth system science with the goal of addressing society's challenges. And in particular, one of our big strengths is playing a role as really bringing together and empowering the scientific community. So to do that, you may be aware, and I'll talk a little bit more about this as part of what M cubed does, our world-class community atmospheric models, high-performance computing and services. We have major research instruments, including observational data sets, and of course we facilitate a lot of field campaign work. We also do workforce development, both partnering with the universities on student development, but then also postgraduate development. And as I said, bringing the community together around scientific problems. So M cubed in particular, we work in prediction and understanding of Earth system hazards. We are one of the 7 labs at NSF NCAR, and our focus is on scales from turbulent scale to convective scale, and really looking at the impacts of those in two-way interactions with the global Earth system. We lead prediction science based on fundamental process understanding and/or innovative use of computational tools, everything from data assimilation to numerics to AI/ML. And we also integrated cross-discipline to also understand the human hazard connections. And as I said, we really focus on the community as a whole. And I will be bringing this up as a theme throughout the science slides to say really we're successful because of the co-development with the community. All right, so kick it off with MPAS, which stands for the Model for Prediction on Scales. This is our new next generation model. It's global and regional. What you're seeing on the right-hand side here is a variable resolution with a focus on the tropics, Atlantic tropics, and it's an unstructured centroidal-Voronoi mesh with the C-grid staggering. C-grid was what was used for WRF too. If you're familiar with WRF, the weather and research the weather research and forecasting model, which was also developed in M-Cubed. So we share the physics suite with WRF in MPAS now. And I want to talk a little bit about what's being developed right now for MPAS. We can say MPAS-A a lot in these slides as the atmosphere part. There's also an MPAS Ocean that is not developed by NCAR. So chemistry is in the works. We're working with the chemistry lab on the Model Independent Chemistry Module, or MICM, but trying to work to replace WRF Chem with ChemPass. Also, large eddy simulation capabilities will be out in MPAS by the end of the calendar year. We have GPU capabilities already released to the community, but only for the DICOR. We have more work to do on the physics. In the data assimilation area, one of our focus areas, we are focusing on JEDI, which is run by the Joint Center for Satellite Data Assimilation. Is a collaboration across multiple agencies, but focusing on MPAS-JEDI development, particularly in the area of satellite DA4 cloud scale applications in a global sense. We also have Earth system modeling capabilities. So MPAS-A is being employed in the NOAA UFS and also the Community Earth System model here at NCAR. So on the right-hand side, you see a forecast for 60-hour accumulated precipitation. And I'm going to actually talk a little more about this particular application in a few slides. All right, so another area before I get into the forecasting is some of the idealized research we're doing with MPAS. So MPAS exists also as an aquaplanet. Let me start the simulation. So that first one was some sea surface temperature, background state, and then the cell spacing. So the highest resolution is over the tropical area and then coarser at the poles. And what you're seeing is simulation at high resolution of the entire globe. So I want to point out, you see a lot of tropical cyclones and also even some transition into extratropical cyclones. We're going to focus on some convective tropical cyclone initiation in just a second as we zoom in on the simulation. So there you see we have an actual formation and intensification of a tropical cyclone. So there's a lot we can do with this. This and other runs simulations I'll be talking about today. We're really happy to share with the community. And so please just reach out if you would like to use any of the data that you're seeing today. So in this MPAS aquaplanet simulation, and I should say this is work led by Rosie Mar-Rios Barrios and her team. And we can see here that this is looking at tropical cyclone formation, and 0 would be days relative to a Kelvin wave crest coming by a particular location. And so this would be happening simultaneously, but we see real peaks here at 2 to 3 days afterwards. So this is making us think there's a significance here for some predictability based on the relationship between tropical waves and tropical cyclogenesis. And I've also mentioned some of the other work that's going on. Can add on here atmospheric rivers and also responses of the whole Earth system. Here we are back to that forecast that I mentioned. This is actually being run as part of, this is a collaboration with NOAA. And so we are running these simulations as part of the NOAA hazardous weather testbed that's going on right now. So these runs will be done through the end of May. These are 2.5-day forecasts, initialized to 0 UTC from GFS initial conditions. Quite a few grid columns to cover the whole globe at 3 kilometers. And we have 55 vertical levels and an 18-second time step. So again, something that we're very excited to share with others if you're interested. And as far as we're aware, this is the first time there's a real-time global convective permitting forecasts happening. So we're excited to see how well these perform. To be clear, right now, all that's being analyzed is the forecast skill over CONUS. So we would welcome partners to help us do analysis of forecast skill over other areas. Yeah, we're excited about this happening. In addition to the simulations we're working on, we're also collecting data from humans. So we need to know, hey, maybe this is a great forecast, but if we're not giving people the information they need, then we're not answering the right questions in prediction. So we are collecting data to investigate questions such as how do people evolve in their response to hazards? What are their risk perceptions? What protective behaviors do they act on? And that answering those questions help us determine whether we're actually achieving our goal of reducing harm to society. So in M3, this is work led by Julie DeMuth and her team with a lot of other partners across multiple organizations. Developed a novel methodology to ask the same question of the same people over time. And so this is what we call longitudinal panel survey data. And they've used this for multiple types of hazard events. You can find out more in some of the QR codes here, but this has been used to determine information from 3 different landfalling hurricanes and 2 West Coast atmospheric river events. They've collected data from more than 20,000 people. And and what's being shown in these figures are the locations of folks that have been surveyed. So we see 2 California cases here for the atmospheric rivers, and then southeast locations for the different hurricane events. And the vision going forward, and again, we're really welcome partnerships in this, is to create a facility for longitudinal social observations to serve the entire weather community. And so we've partnered a lot with NOAA on this one as well, and with university partners, and we look to further formalize this. And it'd be great if we could collect this information more frequently. All right, another type of prediction work going on in M3 and across NCAR is machine learning. So here we're doing post-processing to improve the prediction of severe convective hazards. And hazards, we mean tornado, wind, hail, and lightning prediction. So, and there is improved prediction compared to non-machine learning baselines, in particularly in the more extended forecast area and for hazards that are particularly hard to forecast. And these, again, collaboration with NOAA and the Weather Service, so thanks for all the collaborations on that. If you look to the right-hand side here, we see that in the small inset, this is, you can sort of see some of the states here, Illinois, Kentucky. So this is for a Kentucky outbreak, and you can see numbers. Those numbers are the probabilities, and this is for day 1 of a tornado touchdown. And the pink numbers are hard to read, but that just means the probabilities are highest in those locations. The gray dots show where there was actually an observation. So you can see we don't have perfect predictability, whoops. But there is skill in this. And then on the right-hand side, we're seeing for a particular location where there was a touchdown of a tornado. This is Mayfield, Kentucky. That as we go back farther in time, we actually did show there was probabilities for a tornado touchdown far back in time, several hours, and then we did see that occur. On the bottom here, this is combined all types of hazards, so all the types of hazards possible for medium range, so a particularly interest in days 5 and 7, which are very hard to do right now. And again, we see the numbers show the probability of any type of hazard occurring, and the gray is that a hazard did occur, and we see some skill even for the day 7 forecast, which is really exciting to see. And this is led by Ryan Sobash and his team. This does also include work with DJ Gagne, David John Gagne, which I'm going to mention in a second as I sort of talk more generally about AI/ML work going on at NCAR. We all are aware this is a priority right now to move into this space, and it's would be exciting to partner with any of you on this. NCAR right now is putting together a roadmap, which is just a strategy for how do we accelerate Earth system science breakthroughs using AI/ML in many different ways. We also really have as a high priority democratizing access to AI. So in the same way that we democratize access to modeling systems or observational platforms at NCAR, we'd like to do that for AI and also facilitate workforce development. So this is really in building off of our already computational data infrastructure strengths, and also building on our ability to co-develop technologies with the community. And so now I want to go to the next slide here and talk about this model credit. This stands for Community Research Earth Digital Intelligence Twin. Much easier to say credit. This again led by David Giangani. That's actually in the CISL lab, which is the Computational Information Systems lab here at NCAR, but collaborating with many other labs here and with, again, university and agency partners. So right now, this is up and running. You can find out more on our websites, but it's really helped already as a research platform to understand how these ML-NWP models, or the, I'm sorry, ML-WP models work, and to build best practices. And so, but now we're looking to make it into more of a community AI platform, and putting together the roadmap of how to do that. There will be a workshop later this summer. If you're interested, please reach out to learn more, or again, look at our websites. So that was a very fast path through a lot of science going on. And of course, there's a lot of other science going on in microphysical work, more convective outbreaks, all kinds of things. But this was just a taste of some of the exciting work we're doing in M-Cubed and at NCAR. I now want to move on to the second section, which is a reflection on the weather research community. And here I want to thank lots of people from across the community that I've had discussions about. Really, this is coming from my own wrestling with how do we show up right now? How do we approach the weather? Thinking about the weather research community in really unprecedented times. Here, starting out, is just a couple examples from headlines from just last week. And frankly, there was more stuff that came out on Friday after I put this together. So the big takeaway here is things are rough. There's bad news a lot of the days. It seems like every day. And this is the reality that we find ourselves in. So how do we orient ourselves in that space? I wanted to sort of also first, reflect on our value. So this is pulled from a policy program study from AMS that just came out last month, really talking about the value of the weather enterprise, and that you see here in this figure, we are trying to accomplish our goals of protection of life and property, of facilitating economic growth. And it's really, we've been so successful in this by having strong partnerships between the public sector, the private sector, academic, and non-government organizations. ESIC itself, I think, is a great example of that type of collaboration, and it's been very successful. But this study also points out something I don't think is a surprise to any of us, that if you weaken one of these pillars, these collaborative partners, this weakens all of the partners. It's a very integrated system. And also, not a surprise to us, it's very valuable work. So just looking at it from an economic standpoint, the value of weather and climate info to US economy is estimated at $100 billion per year, which is a 10-time return on investment going into from federal dollars. So great, we know it's a real value, but I'll just say myself individually, I mean, I'm so proud of this. I hope everybody listening right now is so proud of this, but it doesn't really help me right now because I'm like, well, we know it's so valuable. We're doing a good job. Why are we being cut? You know, why is support being reduced so dramatically? So, you know, how do we show up? How do we figure out how to orient ourselves in these times? That study that I just shared and many others like it, which is all great. We want to do all that, keep indicating and advocating the value of our work. But even if we restored all investment right now, just immediately, we've already had damage done. Colleagues and students are leaving the field. There's observations that already are not happening. And there's research that's been frozen and expertise has been lost from the field. So what I'd like to talk about in the remaining slides is a charge I have for myself, and I'm hoping to you, which is employing our creativity to envision our change. Change is happening right now. So how do we step up and be creative about how we will change and how we might improve? There's also a space here of, I'm pulled a Maya Angelou quote here, that hope and fear cannot occupy the same space, invite one to stay. There's a lot of fear, understandably, because there's so much uncertainty right now. And I'm not saying that we're not going to feel the fear and the uncertainty, but I'm hoping that we can be intentional in choosing hope. And I'll also say, I'm going to just put a note here. I mean, I'm a scientist. I'm guessing some of you hear all this and be like, oh no, she quoted Maya Angelou. This is one of those hope talks. I'm a scientist. I'm very pragmatic, and I want to convince us all that our community needs to adapt. So that's what we're good at. We're good at being creative. We're good at using our intelligence to come up with plans. And so let's lean in on that and do that. So, all right. So there was a recent book that came out by Martha Beck that talks about how our brains work. And it turns out that creativity and anxiety are incompatible. So if you're being creative, it's impossible to be anxious at the same time. Like our brains just can't hold those two things at the same time. So there's a real personal benefit from being creative, using our creativity. But what do we want to use it on? All right, so can we make our jobs about more than just survival right now? What do we want the future of the weather enterprise to look like? What will we create? Can we rally around our future, which is not some, there's the future looking ahead, but there's also the right now. With all that said, I do want to take a moment here to say, if all you have energy for right now is to take care of yourself, then that is okay. Take care of yourself. Everybody in this audience is needed to be part of putting together our plans for the future to figure out how we can continue to benefit society. So I want you to take care of yourself so that you can engage when you are able. I often tell I have told my own staff, I can't engage all the time. I think it's at least once a day that I read something, or I'm just thinking about things on my drive into the office or whatever thing. And I just feel overwhelmed by the uncertainty. I'm just deflated. And so I know I have to take a moment and just sit with it. I have to take some deep breaths. Maybe I need to take a walk. Recently, someone pointed out to me, New York Times says maybe you should lie on the floor. I actually tried this for last week. For real. I was in this office and I laid on the floor and I took a few minutes with deep breaths. It did make me feel better. And also I noticed, which I'd never noticed before, that it turns out there's two different kinds of ceiling tiles in my office. So who knows, the scientist never shuts up in my brain. But yeah, please take care of yourself. All right, and that builds into individual resiliency. So I will say everybody, again, here today has had lots of different experiences, but many of us have not experienced this type of career disruption before. I do want to recommend here, if you're interested to check out Marshall Shepard's article from just late last month on passion or pragmatism in Forbes. It's advice for aspiring scientists. So it really is geared at students, so very early career. But I think I still enjoyed reading through what Marshall had to say. A big takeaway from that article is do not ever give up on your passion. Oops, I have a typo there, on your passion, but have a plan B. And I want to say, he's also saying you will be okay. And I want to mirror that. You will be okay. I will be okay. It's good to reflect on the many, many resources all of us have. Again, Marshall's article talks about how our skills can be applied in many different ways, and also our intelligence. Lean on your community, whether that's professional or personal, and please ask for help. So I want to talk a little bit of my own journey in my career, and forgive me for a little silliness here. You know, things are not good, but I'm always going to be silly. It helps me get through my days. So here you go. I'm sharing with you my first role model from when I was a little kid. You know, I know so many people talk to me over my career about their own choices, and I used to be a professor. So how do they get into working on weather? And they were weather nerds from very young. I was a super duper Star Wars nerd from very young, and I was pretty much, yeah, I wanted to be Princess Leia. I did realize that eventually that is not a job. So actually, I grew up in the 80s, big time for the space shuttle. I decided I wanted to be an astronaut. I was sure that was my calling. I subscribed to Sky and Telescope, like in middle school, like I was a super space nerd, really into it. And I had my whole career planned out, and I went off to college with this in mind. But while I was in college, things sort of fell apart. I lost the funding that I thought I had, couldn't, you know, and then that just sort of things started to unravel, rug pulled out. I was devastated at college, and my whole plan gone. Didn't know what I was doing. It was not a great experience, but I did end up working in corporate for a while. I worked for a financial portfolio company doing computer support back in the early 90s. And I learned a lot from that. But what I learned most, and which I wish I could go back and tell myself, was it is not a weakness to ask for help. And I hope we'll all remind ourselves that today. It is tough what we're going through, so please ask for help. No matter what your career level is, it is always okay to ask for help. It is not a weakness, it is a strength. I had to learn that, and something I wanted to leave you with today. I also want to say, some of us have had the experience where we asked for help and we got dismissed. That's not really a problem that you're telling me, or the person just didn't have the capacity at that time to help us. Ask again. Do not give up. Sometimes it doesn't mean you don't actually need help. It means that you just didn't ask the right person. So I would include myself in someone you can reach out to, but do ask for help. All right, moving on from individual resiliency, now getting back into the community. I said I'd talk about the community. So resources are being limited for, you know, whether it's overhead for universities being challenged and grants frozen, whole branches of investigation being shrunk. We are under resource limitations, and our brains were wired by evolution to benefit from a us versus them mentality, which is not great for building community. But somehow we also evolved to understand that resiliency comes from having a strong community. So resilience from an anthropological standpoint means the ability to recover quickly from unexpected shocks and crises. And that could be through adaptation, through resistance, through robustness. Community resilience happens by leveraging resources, being adaptive, emphasizing social cohesion and connection, and really sharing responsibility across the community, and through communication and information sharing. And I've seen all of this take a hit, especially some information sharing, because of resource limitations. We've all I think our community has a bit contracted in, which again is a very understandable response to resource limitations. But I think as a community, the scientific community is incredibly resilient. And to remain so, we must, instead of shrinking in, be intentional in our collaboration and partnership. So the barriers to collaboration, they're not new. They've been around for a long time. Financial pressure is a barrier that I just talked about. It's hard when we're being limited in resources and not everybody's going to get support to not just grab all the support for ourselves. Our value metrics are a barrier. Historically, our scientific institutions have measured easy products, that things we can count. We like pretending we're objective, so like publication counts, but we should be measuring harder things like positive societal impacts, which really happen by us partnering. Our own education is a challenge. So I know, getting a PhD, I've been trained to take apart a big old problem and put it into smaller and smaller pieces until I see the one little piece I'm going to work on next. I'm going to solve it. I'm going to tell you why it's important. So in some ways, our ways we work together, we don't even know what we don't know. We're not good at really true co-ideation. And it's something that we, again, should be leaning into, especially in times like now. And then trust is tough, right? How do we trust each other? How do we trust that wins will be shared? If we have short-term winners, how do we make sure everybody's a winner in long term? And how do we make sure that we're giving everybody, acknowledging everybody's contributions? These barriers are real and they're significant. But if we think again about our passion, and back to our value, why do we do this? We want to make a difference. We want to improve outcomes for society. Then we know, okay, to do that, we have to collaborate. We have to overcome these barriers and be intentional in our collaboration. And that's what will actually make us competitive. And that's what will lead to sustained success. Again, our goal, work together to improve human safety and well-being through scientific advancement. That happens through collaboration and innovation. Again, times that are tough, all the barriers to innovation just jump up, right? There's strong overlaps actually with the barriers I just talked about with collaboration. Funding pressure, our value metrics, the way we're educated to take a next logical step instead of sort of pushing ahead. There's a fear of failure. This leads to risk aversion. A lot of our institutions are fairly risk averse, but to be honest, it's never a good thing when we're all quoting Winston Churchill lines, but this is where we are. Never waste a good crisis. And I do think we have a crisis going on. One of the things that ways it lowers barriers is those we have less to lose. It's time, if there's ever a time to take a risk, it's when it's a time like now. All right, so prioritizing the innovation. So coming back to ourselves as individuals, we have limited time and energy, but can we commit to intentionally using our energy to prioritize relationships, to prioritize team-based approaches, to co-ideate along critical and vexing problem spaces? So this is bringing in those ideas of convergent science, if you're familiar with those. And prioritize employing our creativity, which I said right up front, to envision our change. So how do we do this at different levels of our career? So if you're in early career, you have this big advantage that you might not recognize, which is your newness. You are not stuck for decades like I am in existing structures and organizations. So you're best positioned to imagine outcomes that we've never even thought about. For late careers like me, we have a real privilege to use to help make space for everyone to be heard and to reduce barriers to both collaboration and innovation. And for everyone, we all belong at this table to talk about solutions, and we can be the leadership we wish for. So we may have wonderful leaders in our own spaces, and we may have not so great leaders in our own spaces. I know my own career, I've had some of each. I very much remember playing back a TV show, the time where I was working with someone at a former institution of mine that was at a top position and telling me that the wrong way to lead was by trusting people. And I remember how gut wrong that seemed to me, and I have been able to take that and work against that. Hey, we do need to trust each other. That's how we're successful, and bring that into leadership spaces. All right, so I'm wrapping up here. We'll have plenty of time for a discussion. I went through a little faster than I thought I would. So science is needed. We are being forced to rapidly evolve right now, whether we want to or not. So let's take leadership of that evolution. So what are the next steps? Okay, so I said all this. I hope you found something useful in here, but I don't know what the next steps are. I have one idea is to do some scenario building. This is building off of some ideas in ideating like approaches to dealing with challenges, is to make a 2x2 grid of possible spaces that we work in and look at the challenges in those spaces, look at opportunities, and then figure out some actual actions to take. So what 2x2 space might we look at? All right, so on one axis, I'm going to put integrated response to mitigating hazard risk. Well, that's very wordy, but this is basically saying, hey, let's work together to help humans be safe and to improve outcomes for society. And integrated here, I mean integrating across individuals, across institutions, across disciplines, and across communities. And to the hazards I'm talking about are all of the type of Earth system hazards that we all work in. So we're actually, the weather enterprise is really already a very collaborative space. We do have room to grow. I think our risk right now in the space is that, as we've talked about a little bit, we could go the wrong, I'm hoping we increase our integration. We have a risk of decreasing because of all of the challenges facing us and the resource limitations triggering us to be more insular. What do we want to put on the other axis? Again, there's a lot of ways to do this. I don't have all the answers. It's just one idea. Public trust in science is very much impacting us right now. Trust in science, not great right now. This is not something we control. There's a lot of what's going on right now we don't control. But we could work to make this dot go towards more public trust and not in the opposite direction. If we put these two together, we have a quadrant where we have some integration in our responses, but we're low on public trust. Of course, we hope we can go up into the upper right quadrant, but we could work together to define what these 4 quadrants are, to think about the challenges and opportunities in all of these spaces, and what actions might we take to head towards our selected outcomes. So thanks very much for listening today. I really do welcome all of you to reach out. Anyone that's interested in either, and please, you can ask questions about the science that's happening in M³ and at NCAR, but also if you're interested in what I'm going to say, joining the team. There isn't really a team yet, but I hope we can work together in our current spaces to envision a future. Thank you very much.
Thank you, Dr. Mullendore. So now, if anyone has any questions, you can raise your hand and I will cue you, and everyone should be able to unmute yourself. Or if you don't have a microphone or just would prefer me to ask the question, you can type it in the chat. Questions?
So thanks for the great talk. Can you talk a little bit more about the AI and machine learning project going on, and about the MPAS For example, is there any plan to do some DA or reductive transfer related machine learning with MPAS?
Yeah, great question. So there is some work right now in the data assimilation space on but I mean, I think we're still looking more at the classic data assimilation ways of backing out aerosol load, for instance, from top of atmosphere measurements from satellite. But this is a really, I think, fruitful space to also employ machine learning. I don't know if that's sort of what you're thinking of, but obviously our parameterizations and also how we are assimilating satellite data. There's already been studies showing the value there. That's not something that we're doing a lot of currently in-house, but we would love to partner with folks on those areas.
And a follow-up is, and in addition to the traditional large satellite, any plans for the small satellite, CubeSat?
Oh yeah, great question. So I mean, I think that's one of the values of JEDI, which is there are multiple agencies working on doing providing the operator such that we can bring in data assimilation, and that I think this working together allows us to bring in more unique observations. So I myself would love to prioritize some of the CubeSats. I don't know of any that we're currently working on, but I know some that are slated to be launched soon that would be of high interest. For instance, INCAS, which should get vertical velocities globally, would be terrific to see how that can improve our convective scale representation. Also, I'll mention there's a big push right now at NCAR to assimilate more field campaign data. So that's not exactly what you're saying with the CubeSat, but this idea that we get more observations from less traditional platforms into the models and see how valuable those could be for research and for operations.
Thank you.
So AK had a question. Do you want to ask that verbally, AK?
Hi, I want to ask a question. How this NOAA OAR is really affecting, badly affected or almost get eliminated. So how it is affecting NCAR, because they both focus on basic science in different ways, and but OAR is really GFDL or a lot of other places. So I just how it, I mean, they're with the NCAR, they have a lot of collaboration. So I just want to know how NCAR is really working on that.
So, I mean, I do think that's a great example of leaning into the collaborations, and I think we could do even better of sharing information, but because it's really even hard to get information out on what exactly is going to happen with OAR, but likewise, what's going to happen with NSF. And so there's a lot of uncertainty right now. But we are trying to work together already to sort of save data sets and even instruments. And I think this is what I'm thinking, as far as like, how do we move forward? What areas do we need to prioritize such that we can move ahead doing the most important science in whatever way that looks like? Things have already changed, and they look to be changing more. Well, everybody's talking about reorganization, NOAA, NSF. I think NASA's still looking at what will come down the pike. So want to encourage us to be intentional in that space and really get together and talk about how we're going to continue the science that needs to happen. Unfortunately, I don't have any answers on what is going to happen because none of us know exactly. But I think as facts come out, let's work together to continue the work that we all want to see continue.
Thank you.
We have a question in the chat. As scientists, what can we do to protect ourselves in the future and in the present?
Yeah, so I mean that's a very big question. I thank you all for your questions. There's a lot of levels of protecting ourselves, right? So I mean, I think you have to look at it's okay to look at all the levels. We need to protect ourselves and our families as individuals. So what does that mean? Are we going to be able to deal with the uncertainty of our work right now? Again, depends on who you're working for and what the situation looks like. But, I've said to my own staff, in some cases, it might be that I'm helping them find work in another field. It's a very sad space, but that's, I think, ultimately my job is to help others be successful, and that can mean a lot of different things. As a science community, protecting ourselves, I do think there's a lot of work going on in the advocacy side. I purposely am not talking about the advocacy side here. I'm talking about what we can do to be envisioning our future space as a science community. But I do hope you're getting some feedback from your own institutions on, what does it mean to, there's a lot of things going down that may or may not be appropriate. I need to be careful here as somebody who works for an FFRDC, but I do think I would encourage you to not only sort of think about the things that I talked about today, but also look at all of the advocacy that's going on that really is outside of the FFRDCs in the community, like things that AMS and AGU are doing, for example, to think about other ways to answer that question. I'm sorry, that's pretty vague. So.
Thank you. Jennifer, do you want to ask your question next?
Sure, thanks. So this is a really good talk. Thank you. So earlier you were saying that there's a lot of people, especially a lot of young people leaving the field, which I think is really devastating. But I was just wondering if you have advice for someone thinking of entering the field, given the environment. Like someone who maybe hasn't decided yet, but is thinking about entering meteorology or some other environmental science right now.
Yeah. Well, I think we have to be, I think this is sort of what the Marshall's presentation spoke to. If I can go back to that slide, this article by Marshall, because, don't give up on your passion, but have a plan B, I think is an excellent way to think about it. Because man, if you love working in earth science and environmental science, like and myself also as a former professor, I'm not going to tell anybody don't do that. But there is so many skills that we build as part of that space that can be useful in a lot of fields to give people some flexibility while maybe there are not so many jobs. I mean, the job market does not look good right now, right? So, in a way, this also resonates with the talk about how do we protect ourselves. We have to be thinking about how do we engage in the things that we love, but also be pragmatic about how do we build a career. And I think it's also good to know, which you don't see it when you're early in your career, but most careers, or a lot of careers, I've talked to somebody, my own career looks like this, lots of other people are really windy. There's like, oh, we started here and learned a lot about this and then went over here and learned, again, when I was, my time in corporate America, I was not working on directly on anything earth science at all, but I learned a ton about how financial markets worked and sort of the value of earth science in that space and how corporate America works. It was all very useful for me. And I would say there's a lot of ways to engage. So I think just being authentic with people is really important, right? We should not pretend everything's going to be just fine, but that doesn't mean we can't figure out how to make space for people.
Thank you.
Do we have any other questions? I actually have a question if nobody else does, but I want to make sure everybody else asks a question first. Okay, I'll ask mine. So forgive me if you did say this, Dr. Mullendore, because I had to step out right when you were on this slide, but you had a slide where you talked about value metrics. And talking about, scientific institutions have easily measured products over harder to measure outcomes. I am the communication manager at Essex, so I'm really trying right now to figure out how do we quantify things like that, outcomes. So I was wondering, do you have any tips or suggestions for scientists or people that support scientists to measure or quantify and communicate outcomes like those that you stated, like positive societal impacts?
Yeah, so it does need to be a team approach, right? Because I think that, again, so let's just take this example that I gave, which there's many examples of this, but so publications are important. So I'm not saying we don't track publications, but we are not measuring some things we really want to measure, which is like how have we impacted society in important ways. And another great example is that I'm really talking about team-based science here. Again, a way that our value metrics have made it hard for us to collaborate, hard to do team-based science is it's hard, it takes longer. We have to spend all this time building relationships and actually co-ideating even what the problem is and then coming up with solutions and learning how to communicate with each other across disciplines. So I think that if you're a more early career, talking to people in your institution about how you can show that. What are the ways that your institution shows it tracks your performance? Is there ways that you can show it? But then, myself as a more senior person and in leadership, we've been trying to change it. Like, how do we need to change the way that institutions track performance? And, if we can't change that, and then people say, oh, okay, great, I should be doing team-based science, but I'm not going to get promoted or I'm not going to get valued for that, then we've set up a big barrier. So I think we have to work on it together. But if you're feeling that this barrier is something that you're dealing with, you might reach out to something I didn't say in this talk yet but I sort of hinted at when we were asking for help, but even working through being part of a team to talk about solutions and thinking about new spaces and what are the most important problems to work on. Again, it doesn't mean you're in a bad institution, but you may be right now in a group that's got too much pressure on it. It doesn't have room to think about different types of metrics. Reach out to other organizations, reach out to me. We really are trying to work as a community to solve these problems. So again, that was a pretty easy question, but it's not an easy answer. So, but I think we have a lot. This is something we really need to change. And again, maybe the time is now. We need to change. This is one of the things we can change.
Thank you so much. Does anyone have any other questions while we still have Dr. Mullendore?
No, Cassie and Gretchen, I just wanted to apologize for coming in late. I was actually supposed to be there to introduce you, and I was frantically trying to log on, and Zoom asked me for a password, which has never happened to me before, so I had to scramble and figure out what that was. But I heard your talk. So at least there is that, and it was very interesting. So thank you very much for joining us.
Well, Lars, nice to meet you, and no worries about being late. We've all had technical difficulties at over time, so yeah, no worries at all. Thank you.
Okay, well, if there are no other questions, I think we can wrap up. So thank you everybody for coming, and thank you so much to Dr. Mullendore for giving us this great and very timely talk. We will continue our seminar series. I think next week might be our last one, and it is in person. So you will all see that announcement tomorrow morning. So thank you everybody so much. Have a good rest of your afternoon.
Thanks, everyone.